Okay, so we are going to start with the creation of our first VI, and then we are going to simulate it, and then you will see how to create a VI, how to simulate your program, and then we are also going to discuss how you're going to save your files in version 2013, because that's the version that I have. And if you are saving your files in any version which is higher than 2013, then I will not be able to open those files. So I will show you how to save it in version 2013, even if you're using any newer than 2013 version of LabVIEW, and most of you will be using 2020. Uh, so let's just start. Let's gonna go ahead. We're gonna go ahead and create a new VI. And as we discussed in our introductory lecture, that you have two windows. You have a front panel where we are going to put our components that we have to present, and then the connection and the logic to operate those components will be done in the block diagram. So the first thing we are going to do is we are just going to create a simple um, control system in which you have an LED, and then you have a button, and you're just going to operate that LED with the button. Okay, so you have, as I discussed with you, control palette is associated with front panel, and in the control palette you have different libraries and sub-libraries. And as you can see, you have modern, silver, system, classic, express, and then if you expand this, you can see then signal processing add-ons, and there are some more libraries. You're not going to use all of these libraries. The most common library that you use is Express, and then you have sub libraries or sub toolboxes, numeric control, where you have basically functions, not functions, but controls that you can use to enter different numbers. So one of the most common ones that we use pretty much in every program is numeric control or number control. You also have fill slide, pointer slide, knob to change the numbers, and so on and so forth. If I go back to the Express library, then you have different type of buttons, which is a sub-library or a toolbox. And you can see that you have different types of buttons that you can use and or switches. You have numeric indicators, which again is the library that you're going to use very commonly. And numeric indicators are basically the controls that you use to represent a value or a result. So this is how the palette is divided. It is divided into main libraries and then sub-libraries. And each sub-library has multiple functions or multiple controls. And same is true for the function libraries or function palette. You have libraries, main libraries, and then you have sub-libraries, and each sub-library has different controls or different functions in this case. Of course, these are function, this is function toolbox. So one of the most commonly used control in the front panel is your express control. In express library or express control, you have most commonly used controls systems or control tools. They are collected under express library. You can also find a lot of good control switches or control tools in the classic library, in the modern library, and we're going to discuss some of them. Also, if you don't know where exactly any control tool is located, you can always search that. For example, if I want to know where graph is located, so if I put graph, it's going to show you these are different types of graphs. XY graph, classic under classic graph group, XY graph under graph group, 3D line graph, waveform graph, and we're gonna discuss graph, and you're gonna do graphing in LabVIEW as well. So you can just press any graph, let's say Express XY graph, and it's going to show you the subtool box is going to go to the main library and the sub library, and then the function or the control where the one that you're looking for, or perhaps you may be looking for. And if this is not the one that you're looking for, you can look for some other controls in the same group, and maybe you will be able to find that. And if not, then you can go back to the search, and you can look for something else. Let's say LED, and then you can see that there are a bunch of LEDs and they belong to different libraries and sub-libraries. So if you click on any, it's going to take you to the library and the sub-library, and then you can find the specific LED that you're looking for, round light and stuff like that, square LED. Anyways, so let's say we have a square LED. You're going to go ahead and put that. And let's say you have a switch, a toggle switch. Okay. So what we are going to do, and I'm using classic library, but the most, again, as I said, the most commonly used library, and perhaps I'm using that in my tutorial as well, is the Express one. In the Express one, you have the LEDs here, and you have the buttons or switches over here. But in any case, so Boolean, each type of control has its data type. Boolean means that it can only operate as a true and false, 1 and 0, right? So that's the data type of switch, and that's the data type of LED. It will be either on or it will be either off. Now, some controls are the output controls. They can give output, and some control takes input, and they are operated by the output. So in this case, the switch is an input. So you are giving an input signal, and you want to see the output in the light. Or in other words, the output of the switch is coming into the input of the light. So when you're turning on and off the switch, light should turn on and off. You can change the name of anything. Let's say I want to call it my light, or my switch, sorry. And I want to call this my light, my LED. So you can change the name and observe the equivalent function blocks. As soon as you put these control blocks here, the equivalent function blocks are located in the block diagram. And observe the data type is true and false, which is right here, true and false, because they are Boolean types. They interpret Boolean type of data. Now, you can only connect the controls or the functions that have the same data type. If there are different data types, you cannot connect them. As soon as you will connect them, the wire is going to be broken, and you can see that if the wire is broken, then they are different data types. Now, it's possible that you can convert the data type of true and false into decimal data type, like 1 and 0 Boolean convert into 1 and 0 decimal. And once you convert them into 1 and 0 decimal, then you can connect them to any function that can operate the decimal numbers. And actually, there is an exercise in which you are going to do that. In any case, so this is the easiest type of control system. So what we are going to do, we want to turn the switch on and off, and we want the LED to turn on and off. So all we have to do is to take our mouse, and all the connections, remember, are to be done in the block diagram. There will be no connection that you will be doing in the front panel. Front panel is just for the representation, just for the presentation. So take your mouse close to the arrow, and remember, arrow, if it is on the right, that means signal is coming out of that control system or control tool. And if the arrow is on the left, that means it is taking the signal in. So this is taking the signal in, this is sending the signal out. And you're going to connect the signal to where it is going, right? And since our tool palette is in the automatic right here, in the automatic tool selector. So as soon as I take my mouse close to the connector, it will convert my mouse into the wiring tool. If it is not in the automatic tool selector, then you will have to go and select the wiring tool. But as I mentioned in my introductory lecture, that just leave it by default. It is in the automatic tool selection mode. Just leave it. Don't even touch the tool palette. Okay, so now this is my switch. This is my LED. Let's go ahead and see if it will work. Now there are different types of execution buttons right here. If you press the single arrow, it's going to run it only once. It's going to run the simulation only once. If you do the recycle arrow, it's going to run it continuously. Of course, when it is running continuously, you can stop it and you can pause it. Okay? You can also change the font size if you want. You can change the font size. You can change the style. You can justify it. You can change the color, and you can change the font. So there are all these fonts, which are basically my system fonts. You can use any of the font for any of this text. Okay. All right. So I'm going to run it continuously. And then when I turn the switch on and off, as you can see, my LED is turning on and off. And then I can stop it. If I run it once, based on the location of the switch, either it will turn it on or it will turn it off. Right now it turned it on, and I run it again, it turns it off. So many programs you want to run continuously. There are some programs that you just want to run only once. For example, if you have, you're going to study while loop and for loops. Those things you only run once, because the loop itself is going to keep running as long as the condition of the loop is satisfied or not satisfied, whichever you're going to design. So those cases you only run once, but many programs you have to run continuously and then change whatever you are changing in your program and see what the result is. So this is the simplest type of program, as you can see, and it is also discussed in the tutorial. Now any component in the block diagram or in the front panel, it has many different functions or many different things associated with it, and you can do right click and you can see visible item. Right now the label of the item is visible. You can make it invisible. I'll keep it visible. You can find the terminal, change to control. What does change to control means? So anything that the arrow is on the right side, those are controlling things because they are controlling some stuff. And anything that has the arrow on the left side, those are called indicators because they are indicating some result. So many things you can change to control, change to indicator. You can create a local variable. You can replace the component by some other thing. Data operation. You want the current value to be default, or you initialize the default value. So anything that you do, you have many different functions available with the right click of the button. If you go to properties, you can change the colors of the LED. When it will be on, you can choose it can be green. When it is off, you can choose. If you don't want it to be black, you can choose any other color. So you can explore that many functions that are available. Likewise, if you look at the switch, a good thing with the switch is the mechanical action. So these are different mechanical actions. Switch when pressed, which is the default. Switch when released. So when you release the switch, then it's going to do the function that you want it to do. Switch until release. As long as you don't release it, it's not going to do anything. Latch when pressed, so it's going to change into a latch from a switch. So there are many other mechanical actions that you can change the switch, mechanical action of the switch, and then it can change how it operates. All right. So let's say you anytime, let's say this is one of the exercises that you have to submit, although this is not, right? But let's say assume that this is one of the exercises that you have to submit. The way you're going to do that is, first of all, you are going to write down what exercise number is this. Exercise 1. And let me go ahead and then change my fonts, let's say. Let me change my font to 18 and area black, and assume I change the color to whatever, orange or whatever, right? So this is, let's say, exercise 1, and it's always wise to explain what is this exercise about. So exercise 1, um, control of an LED with a toggle switch. Not simple, let's say toggle. So make sure always write down the exercise number, always do a simple description as what are you presenting in that presentation. And if you just hit save, right? So if you just hit save, I'm just going to save it in LabVIEW data. Then give it a name, and the formatting of the name is going to be your first name, underscore your last name, underscore exercise, whatever the number of exercises, exercise 1, right? So if you just hit save, it would have saved it in version 13. Source version is 13. Okay, now if you are saving it in LabVIEW 2020, and if you just hit save, it is going to save it in version 20. But I won't be able to open that. So what you need to do is you need to save, you can save it in 20, that's fine, but don't submit the version 20. What you need to submit is you go to save for previous version, this option. And then under this option, choose version 13. Now this is version 13, so the default option is version 13, so it is showing you the last option, the last year, 12. So in your 2020 or any version which is higher than 13, make sure you choose version 13. Let's say I choose version 12 because 13 is my current version. 12 is the last version. So I'm just showing you, if I choose version 12 and I save it, it's gonna basically create a folder for that. It's gonna create a folder for that with the same exercise name. And then I'm gonna go ahead and save that. So if I go to LabVIEW, let's see, where did I do that? Document, LabVIEW data. So this is my version 13, which is already opened. So let me go ahead and close that, let's say. Let's close this thing, okay? So this version 13 is the one that I opened it. I saved it as version 13, and I showed you that it was version 13 under the properties. Now if you open this folder, then this must be version 12. So if I open this thing, and then I go and check the VI properties, it will show you the source version is 12. So make sure you save your files in version 13 if you're using 2020 or any version which is higher than 13. And then it will create a folder as you saw. And then make sure you close it and then reopen that file, that is the version 13 file, and make sure before you submit, you check it what is the source version, and make sure it should say version 13. Do not turn it in if it says version 20 or any version higher than 13. You have to submit your work in version 13. Remember that. Okay. All right. Now, so let's say I give you 4 exercises. You can either do 4 exercises in 4 new VI files, exercise 1, exercise 2, exercise 3, exercise 4, 4 VI files saved in version 13, upload all 4 of them, or you can put together all the files in one VI file. Put together all the programs in one VI file. So you can do, let's say this is exercise 1, and let's say control C, and then you can put control V, oops, let me just write down, why didn't copy, I don't know, and control C, control V, I'm not sure why it's doing 5270, anyways, oh, perhaps you know what, let me see, Control C, I have to highlight it, and Control V, here you go. Okay. All right, so now I can do exercise 2. I can also put a line over here if you want. So if you want to put a line or anything, if you go to tools, or actually if you go to, let's say, modern, and there's a decoration library right here, decoration. So you can choose a line, and then basically you can put a line between the two exercises or something like that. So you know that these are dividing two exercises, so that's going to be better. So exercise, let's say 2, and we can do whatever you will be doing in that exercise, right? Let's say uh, mm, evaluation of f x comma y equals 4x plus 3y plus 6xy minus 7x cube. Let's say you want to evaluate this formula for different values of x and y, and this is your exercise 2. So either again you can create another VI file for this exercise, save it in version 13, or if you want you can keep the same VI file and then do the second exercise. Okay, so we are going to discuss the mathematical operation and function evaluation in our next video.